Hi, Rockstars. Today we will be moving forward in our chemistry ignition series, in our atomic structure series, and today we will be taking the second part of this topic. And in this class, we will be splitting the lesson into 4 different sections. In the first section, we will discuss the concept of isotopy. Secondly, we will be addressing the concept of relative atomic mass. Under this section, we will be learning how to calculate the relative atomic mass using percentage abundance and even ratio. And thirdly, we will be addressing the concept of relative molecular mass. We'll also be calculating relative molecular masses of compounds and percentage composition. And lastly, we will be using all this knowledge to crush UTME questions. Stay with me. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to smash the subscribe button, turn on the notification. Let's get started. Remember, in our previous class, in the part 1 of this series, we explained the modification of one of Dalton's atomic theory, where it says that atoms of the same element are exactly alike in all aspects and differ from atoms of other elements. Where we said the phenomenon of isotopy nullifies that postulation. Now, isotopy is a phenomenon whereby an element has atoms that bear the same atomic number but different mass number. And these atoms that undergoes or experience or observe this phenomenon are called isotopes. Now, most elements in the periodic table undergoes this phenomenon known as isotopy, but not all. Now, for instance, hydrogen exists in 3 forms. We call this protium, where it has only 1 proton and 1 electron. It does not have any neutron. We call this protium. Then we have the one that has 2 mass number and 1 atomic number. We call this deuterium. It's radioactive. And lastly, it also has an isotope that has 3 mass number and still 1 atomic number. We call this tritium. Both of these are radioactive. They are the secret behind the power of the sun. Yes, through nuclear fusion. So, this, if you notice, they all have the same atomic number 1, but their masses differ. So, another example is chlorine. Chlorine exists in 2 isotopes. We have chlorine 35 and we have chlorine 37. The same atomic number, but their mass number differs. Even carbon exists in 2 isotopic forms. We have carbon 12 and we have carbon 13. Now, in isotopes, their chemical properties are the same. The both of them, their chemical properties are the same because their electron number is the same, 17, 17, 6, 6, 1, 1, 1. But they have slightly different physical property due to their difference in neutron number. Please don't forget, you can even define isotope also as atoms that have the same proton number but have different number of neutrons. The main reason behind isotopy is their difference in neutron number. For instance, in hydrogen, protium, the neutron number is 0. Deuterium, the neutron number is 1. Tritium, the neutron number is 2. Remember, you get it by subtracting it from the mass number. 3 minus 1, 2. 2 minus 1, 1 minus 1, 0. Chlorine 35. Their proton number is the same, but their neutron number, for example, this has 18 as neutron number. This one has 20 as neutron number. Same with carbon. Proton number the same, but neutron number here is 6 and here is 7. So please take note. This is the reason why elements exist in different isotopic forms. Their neutron number differs, whereas their electron number, which talks about their chemical properties, and also proton number are the same. Now, this concept leads us to the next section, relative atomic mass. Due to the tiny nature of atoms, it is almost impossible to quantify the mass of an atom. For instance, the mass of hydrogen atom is around 1.67 times 10 to the power of minus 24. So, gram. So imagine, this is very tiny. Even the microscope can't view it. So most times, always, relative atomic mass is a relationship. That's why it is called relative. Between an atom of an element with a reference point. At those times, hydrogen was used as a reference. That means, for instance, oxygen. The atom of oxygen weighs around 2.66 exponential minus 23 grams, if I'm not mistaken. So, to know the mass, the relative atomic mass of oxygen, it is divided to a reference, which is hydrogen, which will give you an approximate value of around 16. Please take note that relative atomic mass do not bear unit, because it's a ratio of a mass to a mass. So gram always cancels gram. So at those times, hydrogen was used as a reference point. So hydrogen is given what we call 1 AMU, 1 atomic mass unit. That means oxygen, which is 16 times heavier than hydrogen, was given 16 AMU. That means carbon will be given 12 AMU, and so on and so forth. And the mass, these masses were obtained using the mass spectrometer. That instrument is used in measuring the mass of an atom, the mass of isotopes, the relative abundance, the mass of compounds, the number of isotopes of an element. That mass spectrometer gives the accurate measurement of atoms. Now, but in recent times, recent scientists now use a reference point of carbon, no more hydrogen. And that leads to the definition of relative atomic mass as the number of times the average mass of an atom is heavier than 1/12 the mass of carbon-12. This may look complex, but what it simply means is 1/12 the mass of carbon-12. Carbon-12 is seen as 12. So 112 carbon-12 means what? That means it's a ratio where the relative atomic mass of an element is divided to a reference point of carbon. Now that means that if, for instance, let's say sodium is 23 times heavier than 1/12 the mass of carbon 12, which is 1, that makes the relative atomic mass of sodium to be what? 23.0. So recently, if you have been asked to define the relative atomic mass, define it in reference to carbon as the number of times the average mass of an element is heavier than 1/12 the mass of carbon 12. Now, it's expedient to take note that not all elements in the periodic table undergoes this phenomenon called isotopy. For instance, sodium does not undergo isotopy. And that's the reason why sodium, the mass number of sodium is the same as the relative atomic mass of sodium. If you take note, most elements, their mass number is slightly different from their relative atomic mass because those elements undergo isotopy. So they exist in more than one form. But elements like sodium, the mass number of sodium is 23. And the relative atomic mass of sodium is also 23 because sodium does not undergo isotopy. But elements like, for instance, chlorine, that exists in two isotopic forms, chlorine 35 and chlorine 37. Now, to know the relative atomic masses of the isotopic forms of these elements, you must know their ratio of occurrence or their percentage abundance. For instance, 35 is more abundant in nature compared to 37. Protium is more abundant in nature than deuterium and tritium. Same with carbon 12. Now, chlorine 35 is 75% abundant, whereas chlorine 37 is 25% abundant. Now, to calculate the relative atomic mass, all you need to do is sum the percentage of the mass number of both isotopes. Now, this is it. You say 75%, which means 75 over 100, multiplied by the mass number of carbon 35, which is 35, plus 25% of the mass number of carbon 37, which is 37. This will give you your relative atomic mass, which is equal to 35.5. And that's the reason why the relative atomic mass of chlorine is 35.5 in your periodic table and not the conventional 35. So go through your periodic table and search for the relative atomic masses, and you will see them. Most of them are in decimal points, and the reason why they are in fraction is because of the presence of isotopes. So exam body can ask you, why are the relative atomic masses of most elements in decimal fractions? The reason is because of the presence of what? Isotopy. Because elements exist as isotopes. Now, let's advance to the third section and let's talk about the concept of relative molecular mass. Now take note, Relative molecular mass can also be defined based on a reference, as we did for relative atomic mass, where we define it as the number of times the average masses of a molecule of a compound is heavier than 1/12 that of carbon-12. Yes. But in another simple way to define relative molecular mass is that relative molecular mass is the sum of the relative atomic masses of the elements in that compound. I come again. Relative molecular mass is equal to the summation of the relative atomic masses of the elements in that compound. For instance, calcium carbonate is made up of calcium, carbon, and 3 atoms of oxygen. So, how do you calculate the relative molecular mass of this compound? So, please take note. There is no need for you to want to cram or master all the relative atomic masses of elements in the periodic table. It's still good if you can, because most times in questions they always give you. Now, for instance, calcium carbonate, the mass number, most times they give you in mass number, but sometimes they may give you in their relative atomic mass. So always follow what you have been given. For example, calcium is 40 grams, carbon is 12 grams, oxygen is 16 grams. So to calculate the relative molecular mass of this compound, sum their individual relative atomic masses together. That means you say 40 of calcium plus 12 of carbon plus their 3 atoms of oxygen. That means 16 times 3, which is 48. This will give you a total of 100 grams. That means the relative molecular mass of calcium carbonate is 100 grams. This can also be directly measured accurately with precision using a mass spectrometer. Now, the other part is percentage composition. Percentage composition simply means the percentage of an element in that compound, or the percentage that a particular element occupies in mass compared to that of the total relative molecular mass. You can also say it as the relative atomic mass of an element to that of the relative molecular mass of the compound. For instance, the percentage composition of calcium in calcium carbonate, calcium is 40. The total, which is the relative molecular mass, is 100. Multiply, this is percentage composition, you multiply it by 100. This will give you what? 40%. Carbon is 12 all over the total, which is 100 multiplied by 100%, which will give you 12%. And lastly, oxygen. There are 3 atoms of oxygen, which is 48. Please don't use just 16, because this is not just O, this is O3. 48 all over 100 multiplied by 100%. This will give you 48%. Always, to confirm if your answer is correct, sum all the components of that compound. They are supposed to give you either exactly 100 or approximately 100. This will give you exactly 100%. So that's the way to calculate the relative molecular mass and percentage composition. If you've been enjoying this video, rockstars, like it, and also subscribe. Now let's move on to the last section of the class today. Let's go and crush UTME questions. Come with me. Okay, the first question. A silicon containing ore has 92% of silicon 28, 5% of silicon 29, and 3% of silicon 30. Calculate the relative atomic mass of the silicon. Remember I told you, sum the percentage of their mass numbers. So, for the first one is 92%, that's over 100, multiplied by 28, plus 5 over 100, that's the second one, multiplied by 29, plus the third one, 3 over 100, multiplied by 30. So 92 over 100 times 28 will give us 25.76. 5 over 100 times 29 will give us 1.45, and 3 over 100 times 30 will give us 0.9. If you sum all of this now, it will give you your answer as 28.11. So our relative atomic mass of this isotope is 28.11 with no unit. So our answer is what? B. But if I were to be the one having a question like this, and let's say for instance there is no time, I want to be faster, I know that the closest to my answer is this. This is an isotope. Even without struggling to calculate, I already know that my answer is supposed to be 28.11 because it carries the largest percentage. Now let's move to the next question. What is the percentage of sulfur in sulfur 4 oxide? It is percentage composition. And for you to be able to find the percentage composition of an element in a compound, you must first find the relative molecular mass of that compound. Then you will use the relative atomic mass of the element related to the compound multiplied by 100%, and you get your answer. So let's find the relative molecular mass of sulfur 4 oxide. But you will need to know the formula of sulfur 4 oxide. Sulfur 4 oxide is SO2. Carbon 4 oxide is CO2. Nitrogen 4 oxide is NO2. So sulfur is 32 plus oxygen is 16 times 2, that's also 32. That's 32 plus 32, which is equal to 64 grams. Remember the video I showed on how you can easily get your mass number? Sulfur is number 16. Silly in the mnemonic. In the mnemonic. 16 times 2, 32. Oxygen is 8. 8 times 2, 16. You see it? So, our relative molecular mass is 64. Now, our percentage composition of sulfur. Sulfur is 32 all over our total, which is 64 times 100%. This will give us 50% as our answer. So, our answer is what? C. As simple as that. To the next question. Chlorine consisting of two isotopes of mass number 35 and 37 in the ratio 3:1 has an atomic mass, that's the relative atomic mass of 35.5. Calculate the relative abundance of the isotope of mass number 37. If you remember in our former class, if you remember, you don't even need to put a pen to know the answer. Remember we said chlorine 35 is the most abundant isotope of chlorine, and its relative abundance is 75 and 37 is 25. That means our answer is what? 25. But if you want to solve it, the simple way to solve it is from this ratio. Remember, they said 35 to 37. 35 and 37 are in the ratio of 3 to ratio 1. That means 35 is 3, 37 is 1. In normal percentage, to find ratio, to find out 37, you will say 1 all over the total, 3 plus 1, which is 4, multiplied by 100. Which is our percentage. This will give you what? 25%. You see, it's simple. And if you have to find the one for 35, you will just pick the first one, 3 all over the total, 4 times 100. It will give you what? 75. As simple as that. So let's move to the next question. What is the percentage of oxygen in aluminium sulfate dihydrate? And the relative atomic masses, the mass numbers are given to us there. So remember, I said to you that if you want to calculate percentage composition, the first thing to do is to calculate the relative molecular mass. Now, aluminium is 27, so 27 times 2 will give you 54 plus open bracket sulfur is 32 plus oxygen is 16. 16 times 4 is 64. Then you multiply it by 3. Just follow it exactly as this. Then plus 2 open bracket, hydrogen is 1. 1 times 2 is 2 plus oxygen is 16. So just follow the same layout and just substitute your value inside of it. 32 plus 64 will give you 96. So 96 multiplied by 3, it will give you 288. That's 54 plus 288 plus 218 times 2 is 36. So if you plus all of this, it will give you a total of 378 grams. So that's the relative molecular mass of aluminium sulfate dihydrate. Then we need to advance to find the percentage of oxygen atoms in this compound. Now, oxygen, how many oxygens are here? This has a 4 multiplied by the 3 outside. That means there are 12 here. And this also multiplies to that 2. 12 plus 2, that means there are 14 atoms of oxygen. I don't know if you get it. That means we have 14 atoms of oxygen divided by our aluminium sulfate dihydrate multiplied by 100%. Our 14 times 16 will give you 224 divided by our aluminium sulfate dihydrate is 378 multiplied by 100%. We get 59.25%. That means our answer is what? D. You can choose to go further to find a percentage composition of just aluminium or sulfur or even hydrogen. So that's the way to always find percentage composition. The element divided by the total multiplied by 100. So in this case, we have 04 here multiplied by the 3 outside. It will give you 12. And there are still 2 oxygen here. If you do the total of it, you will get 244 divided by our total multiplied by 100. So now let's go on to take the last question. So if the relative atomic mass of an element is not a whole number, it can be deduced that the element is, remember I said to you, the reason why in your periodic table the relative atomic masses of elements are in decimal fractions, not whole number, is because of the presence of what? Isotopes. It means that that element is an isotopic mixture. Yes, rockstars, if you enjoyed the video today, please give this video a thumbs up, like, subscribe, share, and also in the comment section, comment. In the next class, we will be talking about the final topic under the series of atomic structure. We will be talking about quantum numbers, quantum chemistry. You can't afford to miss that class. So please do well to subscribe so you'll be notified when we drop videos. I remain your host Joshua, leaving to catch you another day. Shalom.